Okay, so this one's going to be a short little video, but I just have to make sure I describe this well. So we already talked about oxidation numbers. And so another definition for understanding something that's oxidized, what happens when something is oxidized? So let's take a look at it as a nice simple one. Like we've done calcium and chlorine enough, so I'm just going to keep doing it. CaCl2. Let's identify. Let's do oxidation numbers on each side. So let's do calcium is going to be 0 because it's neutral. It's by itself, right? You might normally think, oh, it's +2, but it's not paired with anything. It's neutral. Chlorine, also neutral because it's in its elemental form. And my zeros aren't really looking like zeros. 0, 0. Over here, on the product side, we have an ionic compound where chlorine is -1 and calcium is going to be +2, right? Okay, so what was oxidized? The thing that lost electrons. Oxidized is losing electrons. Another way to think about something that's oxidized is its oxidation number increases, right? So in this case, calcium was oxidized. Something that's reduced, you can also think it gains electrons, but you'd also think its oxidation number decreases. Actually, how I remember it is the oxidation number is reduced. It doesn't have to become negative, it just has to go down. So in this case, it's chlorine. Okay, let's do this with something that's a little less intuitive than a nice, simple ion formation reaction. Let's do that combustion one I showed a little bit ago. So I'm going to draw it out. I'm going to pause it, write it out, and then balance it real quick. So, okay, first things first, something to be aware of. The coefficients have no bearing at all in identifying the oxidation number. You can just ignore them. They're there for things like stoichiometry problems. They have no bearing at all. So the 5 and the 3 and the 4 have no bearing at all on the oxidation numbers. We're just going to identify them as normal. So a nice easy one is going to be the oxygen. So this is how I'm going to figure out what was oxidized and what was reduced. I'm going to look at what the oxidation number is for each element on the reactant side and then on the product side. So let's look at the easy one is O2. It's an element, it's by itself, it's going to be neutral. All right, C3H8. Okay, so what do we know about hydrogen? Hydrogen is usually what? Hydrogen is usually +1. So, did I do this right? I feel like I did it wrong. I might need to do a different one, I just realized. Give me just a second. Okay, sorry about that. I had to balance this out so it worked better. So O2, even though I've changed things a little bit, this is still 0. O2 is still 0. Everything else is going to be the same. I just need to change this one up. So hydrogen is going to be +1. And because it's +1, there's going to be a total of +6. The whole thing has to be neutral, so we need a -6 here, so each carbon has to be +3. Okay? So +3, no, not +3. What am I thinking? Has to be what? -3. There we go, -3. So now we have our oxidation numbers on the reactant side. Let's go look at the product side. CO2. Well, oxygen is going to be -2, like it kind of always is, right? So that means it's going to be -4. Carbon has to be +4. So over here, oxygen is still going to be -2. Hydrogen is going to be +1. So let's take a look at each element. We want to figure out what was oxidized. What was oxidized? The thing that was oxidized, right, is the thing that increased in oxidation number from the reactant to the product side. So one thing to note, hydrogen goes from +1 to +1. Nothing happened with hydrogen. Hydrogen wasn't oxidized or reduced. Carbon went from -3 to +4. Its oxidation number definitely increased. So carbon is what's oxidized. The thing reduced is the thing whose oxidation number went down because it took electrons. Well, oxygen was 0, and over here in both compounds, it's -2. So oxygen is the element that's reduced. So when we identify what was oxidized and what reduced, we almost always identify the individual element that's oxidized or reduced. Okay, hopefully that makes sense. So this is using oxidation numbers to identify what was oxidized and reduced. Okay, Now, I'm going to throw a weird terminology at you, but this is, I'm going to be honest, this is always confusing to students, and I'm not entirely sure why. Okay, so a thing that was oxidized had to be oxidized by something. So let's say someone gives money to someone else, right? The person who gets the money was the receiver, right? But the person who gave it donated it, right? There's a relationship there, right? That actually doesn't work as well, at least linguistically. I always have these morbid ones that I have to, not morbid, but kind of weird ones. So I'm walking, and someone decides to be a jerk and trips me, right? I got tripped. I fell. However, the other person is the person who tripped me. They're the tripper, right? They are the tripping agent. They are the agent of my destruction. They are the one that caused me to be tripped. In the same way, we have a terminology here. The oxidizing agent. The thing oxidized does what? It loses electrons, right? Its oxidation number goes up. But the oxidizing agent is the thing that took the electrons in the first place, right? It's the thing that causes the oxidizing. It's the thing that came along and did the oxidizing. The oxidizing agent itself, in taking the electrons, is the thing that's reduced, right? So this is where people get confused, because it has the word oxidize in it, but it itself is reduced. You have to think about the way the word is constructed. The oxidizing agent isn't being oxidized, it's doing the oxidizing. So it itself is reduced. And likewise, the reducing agent is the thing doing the reducing. It's the thing that's oxidized. It's the thing giving up the electrons. Okay. An extra little thing. A way we phrase this. Let's go back to this one. So we had C2H6, 7O2 produces, 4 CO2 plus 6 H2O. Okay. And remember, we discovered that oxidized, reduced, carbon was oxidized, oxygen was reduced. The way we refer to the oxidizing agent and the reducing agent. Okay, so when we talk about what was oxidized and what was reduced, we talk about the individual elements. When we talk about the agents, the reason we do this is the part that's going to seem really weird. But this is because in a lab, right, I have carbon in here and I want to get it oxidized. I don't know what form it's going to be afterwards, right? I don't know what form it's going to be. I just need to get it oxidized, right? Well, I need to add a thing. I need to go to my lab, I need to go into my stock room and pull out a chemical that's going to oxidize it. So I need an oxidizing agent. But I'm not just looking, I'm not categorizing. When I go to my stock room, I'm not categorizing it just by the element. I'm actually describing the whole compound that it's in. So the oxidizing agent is the reactant, the whole reactant that contained the thing that was reduced. So in this case, while oxygen is what is reduced, O2 is the compound or the identity that came along and did it. The reactant that did it. The reducing agent is C2H6, right? Because we don't care what when we talk about the oxidizing agent, we don't really care what happens to it afterwards. We just care about it in the sense that it does oxidizing, And the reducing agent, we only care in that it reduces something, right? So we refer to it as its whole compound. So that's a little tricky. When we talk about what was oxidized and what was reduced, we talk about the individual elements. When we talk about the oxidizing and reducing agents, we talk about the reactants. So we're sticking strictly to the reactant side. We're not talking about the products. Don't care about the products. Only the reactant side. And so I find the whole reactant for the oxidizing agent, it's the reactant that contains the element that was reduced. The reducing agent is the whole reactant that contains the element oxidized. So it contains carbon. Okay. Let's do some practice. Take a minute. You're going to have to figure out all the oxidation numbers for all of these to figure this out. This can be very tricky. I'm going to go through it in a minute. I want you to identify the oxidizing and reducing agents for each. All right. So H2O. This is one you're going to get really used to. Oxygen's -2, so that's -2. Hydrogen must be +1 to make it neutral. Aluminum, it's by itself, so it's neutral. Oxygen's always -2. This one's tricky. That means there's a -8 here, but it needs to add up to be -1 because of that. That means manganese is +7. Yes, it can be +7. Manganese is a +7 here. Over here. Now, this is kind of interesting. So we have aluminum hydroxide. You can approach this a couple of different ways. You can recognize that this is hydroxide, OH-, and just balance the hydroxide by itself and say, okay, well, this is going to be -2. This has to be +1, which is a total of -1, and realize that the 4 hydroxides together are going to be -4, right? Or you could do the whole thing at once. You could do the whole thing at once. And the aluminum will be +3, because that's the charge on aluminum, right? And that makes sense, right? We have a +3, then 4 hydroxides, -1. MnO2, -2 for oxygen, so it's -4. It means manganese is +4. Okay, so what element was oxidized? What element was oxidized? Well, it looks like aluminum was oxidized, right? Because it went from a 0, right? It went from 0 to +3. What element was reduced? Well, it looks like manganese was reduced. It went from +7 down to +4, right? Its number went down, it was reduced. Okay, well then we have to figure out what is the oxidizing agent. The oxidizing agent is the reactant that contains the manganese. MnO4-, not MnO2, right? Because that's already been oxidized. That's not going to do any oxidizing. This is the compound that's ready to oxidize something, right? It's got this high number here. It's ready to take a bunch of electrons, right? So that's the oxidizing agent. The reducing agent, right, is going to be just aluminum by itself. Because again, people want to put the reactant or the products down, but the product has already done the thing that we're talking about. This is the reducing agent. It's the thing that's going to reduce something, right? It's going to give up a bunch of electrons to something. So, oxidizing agent, permanganate, reducing agent, aluminum. Okay, next one. There we go. Okay, next one. Oh, this one's weird, but we can still do it the same way we always do it. So -2 for oxygen, that means -10. That means we have to have a +10. That means each individual iodine is +5. Carbon monoxide, -2 must be +2. Iodine is neutral, and then CO2 -2 means it's -4, +4. Okay, should be a plus. What element was oxidized? What element increased its oxidation number? Well, that was carbon. What was reduced? Well, iodine went from +5 to 0, so it was iodine. So what's the oxidizing agent? It's the reactant that contains the thing that was reduced. So it's I2O5, right? I2O5. What's the reducing agent? It's the compound that contains the thing that was oxidized, so CO, carbon monoxide. Okay, down here, barium, Ba2+, well, that's easy, that's just 2+. That's simple. Here we go, -2 + 1, -2, oh, right, this is hydrogen peroxide. This is the one example, one exception I told you about. Oxygen is -1, so there's -2 + 2 + 1. ClO2. -2 oxygens, -2 + 4. Okay, over here, barium still is +2. Now in here we have ClO2-, so the polyatomic ion has to add up to be -1. So -2 means -4, right? So chlorine has to be plus what to make it be -1? Only +3. Over here, H2O, same as it ever was. And then oxygen is 0. Okay. This one, I just realized, is really, really wacky. But not so bad. So, let's take a look at it. So this is going to be easier. I'm not going to give you anything this complicated. This is a little too weird. However, let's figure out what must have been, because the thing that's weird is oxygen. The reason it's weird is you have these -1s and zeros. You have different oxygens doing different things, and it's hard for you to know, as a student, offhand, which oxygen became this oxygen. Was it the or did this -1 go down to 0 or up to -2? Well, I'll show you how we'll figure that out, but I won't give you anything like that. I promise I won't do that. Chlorine, look at chlorine. Chlorine is definitive. I know what chlorine did. Chlorine went from +4 to +3. That means that chlorine must have been what? Right? Chlorine was reduced. So, what must have been? So, oxygen couldn't have been reduced. It must have been oxidized, right? So that means that the oxygen that's oxidized is this one. It's going from -1 up to 0. So now that that's out of the way, the reducing agent is what? It's the compound, the reactant that contains the chlorine, so ClO2. The oxidizing agent is the thing that contains, wait a minute, am I backwards? I screwed that up. I'm sorry. Sorry, guys. Sorry. The oxidizing agent contains the chlorine, because the oxidizing agent contains the thing that was reduced, so ClO2. The reducing agent contains the oxygen, and it's this oxygen, so it must be H2O2. So, sorry, like I said, that one was complicated, but hopefully you followed my thought process. These two are more indicative of the sorts of things I'll give you on an exam.